Hello everyone, I'm Jakub, and today we will continue with our Ktor server, and we will deploy our server on the internet publicly. We have a lot of work to do. We will deal with packaging, actual deployment, and optionally, if we have time, I will also show you how to manage database using Kotlin. So let's immediately jump on it. Let's start with launching Ktor project. You can use the project from the last lesson, or you can just download this zip file in our GitHub. I will send you a link. Where is the chat? Here is the link. And or you can just open a new project as I will and copy files from last lesson. So let's start a Ktor project on AppPort Academy, and it's lesson 10. And on our GitHub, you can go into folder code, and here you can see 3 files. So you can just copy them and modify the project you just started. So let's start with build Gradle. This loads all our dependencies. Then we can copy our expense.kt, which is our data class. Expense. And finally, let's modify application with all endpoints we implemented last time, and also the optional ones. So you can find here even the endpoints for delete, update, or read of single expense. Once we have done this, we can start the project by clicking run. It will take a while to build, and after a few seconds, it will start the project. And let's just validate by making a request to /hello world. Awesome, it works. So we have a project that, as we left off last time. Now we are running this project locally, which means no one outside of our network can actually access it. To change it, we need to deploy project on the internet, and it's actually quite simple. So this is going to be our second task, or actually fourth one. First, we need to package the project. Right now, our project is just a bunch of files that eventually we click run, something happens on the background, something gets built, and the service starts. We can create... Sorry? Okay. If you need something, just speak up or write me something on a Slack or Zoom. Where was I? Yeah, we can package our project, our Java files, some manifests into a package file format, jar, Java archive, and take this file and deploy it to any environment that has a Java virtual Java runtime environment JRE running. To do that, we will use a library called Shadow, which you need to import into your project. So let's add another dependency into our build script dependencies. Add Shadow 520. Also add apply plugin among our plugins. And finally, we need to add a shadow jar Gradle function. This will allow us to package the project into something that's called fat jar. Fat jars are archives that contain not only our source code, our what we actually implemented, but even our dependencies. For example, our dependency is Ktor serialization. So now that we've implemented this into build Gradle and rebuild the project, we can actually click on build and see that this is just a warning. We can ignore it, that our build was successful. Or we can use our terminal and use Gradle W shadow jar. This runs task, Gradle task shadow jar. It takes a while. It actually configure something, execute something. If we would have tests, it would run the tests and validate it that none tests are failing. For now, we don't have tests, so that step is skipped. And we see that the build was successful. Now we got a build directory created, and inside it, we can find a libs folder or directory, which contains our jar. This is the file that can be used to run our server. We can easily run it by using command line java-jar, and let's add the path to our jar file. /AppPort Academy. Oh no, what happened? Okay, my server is already running. I forgot to turn it off. So you can't have two applications listening on the same port. So that's right. So let's try it again. And voila, the server is running. We can again validate by sending this request, and we got response 200. Okay, hello world. So this is awesome. Now we have a package that we can deploy anywhere where Java runtime environment is. We can run this jar. So the next step for us is to create an account on Heroku.com. Heroku.com is a platform that allows running your services in the cloud. It helps you with monitoring, with actual deployment, with managing databases. And I'm not like being paid to promote Heroku.com. I just have an awesome experience with it because I run my personal project there, which is written in Python for like 4 months, and it's running flawlessly. The good thing about Heroku is that it allows free tier, which we are going to use, that allows us to run up to 2 processes. We need only one. And it will give us 550 hours of runtime, which is something under or above 20 days, which is more than enough we need. Of course, there are some downsides, like limited amount of memory we can use or limited amount of projects. And probably the biggest downside is that once you outgrow the free tier, the other tiers are actually quite expensive. So it has some pros and cons. If you are interested in deploying it, I would ask you to create an account there. Simply go to Heroku.com and click on sign up. Fill any first name and any last name you need. You need a working email address because you will receive an email that needs confirmation, and select any role, for example, hobbyist or student, whatever you like. And let's say we are using Java as a language, and confirm we are not a robot, so crosswalks. Awesome. Now, after you click create free account, you will eventually receive an email. This is the one where you need to click on this link to actually confirm your account. I will give you some time to get this done. After this is done, you will be logged in. So let me log in the meantime. And this is the screen that you will see. Now, if you are here, I would like to ask you to confirm by clicking on yes, so that I know that I can continue. Or if you have any questions or something's not working for you, just let me know. I see one yes. So I will wait more. Well, here I think I can also tell you that in addition to what we saw, Heroku also offers free database, which can contain up to 10,000 of rows, which is more than enough for our home project or pet project. So we are going to use this as well if we have time. So I see two yeses. I would like to get one more before continuing. If you have any issues, please let me know. Okay, three yeses. All three are from hosts and co-hosts. Okay, I'll continue slowly. Hopefully, you will be able to catch up. What we are going to do now is to create a new application in our account. The name of the application needs to be unique. So please use different one than I do for Academy, and let's select the Europe region because it may have faster response times. And once we are here, we are shown that we need to use Heroku command line interface and GitHub. So that's our next step. We will need to install Git. Hopefully, since we are all software developers, Git is already part of our environment. If not, you can just go to, oh no, I did not include Git to the web page. So to this address, gitscm.com, and click on downloads. And it tells you, it offers you several opportunities how to install Git. If you use Xcode, it's already installed. If you use Homebrew, you can just brew install Git. And finally, you can download a binary installer from on the internet from SourceForge. The second thing we need is Heroku command line interface. Again, on macOS, you can use Brew. If you're using Windows, you can download installer for your platform. And once you have that done, you can verify your installation by saying git version. It will give you a version of your Git. Heroku version. It will give you a version of your Heroku. And again, please let me know that you are ready to move on by clicking yes. So again, I will show you what we need to do. You need to download Git from git-scm.com and download Heroku CLI using this brew command. Does anyone need any help? looks like no, but I'll give you some time. If you are ready, please click yes so that I know that at least someone was able to get past the installation. Awesome, the first one, great. I hope you had no issues. Meanwhile, let's just say what Git is. Git is a versioning software that helps with writing code in large team or even one-person teams. It helps versioning the source code as you write it. And Heroku uses Git as well. You don't need to know anything about this for our project, but eventually, as you write more and more code, you will get to use it more and more. Now we have two yeses, so one more. And finally, Heroku command line interface helps you with communicating with Heroku platform. It uses Git in the background, and it basically uses, it's nothing extra above it. It just uses Git to version your software. Does anyone have any issues? Is there any way I can help? Feel free to tell me or to write it down. Okay, we got 3 yeses, so let's move on. Now, this was actually the most difficult part, I would say. So if you're able to pass it, great. I think more difficult it's for us. For now, I'll stop the server that's running here, and we can actually start. First, we need to create a repository. This is the only Git command, or not the only one, the first one that we're going to use. So let's type Git init. This initializes Git repository in our directory. You can immediately see that if you write Git status, that we have some files that need to be added. So we are eventually going to do that. But for now, we also need to link Heroku with our repository or with our machine. So let's use Heroku Login, which offers us to open a browser. Let's continue with enter. This opens web browser. And once you're there, be sure to be logged in. And just by clicking login, it will send a token back to your command line. And as you can see, I'm now logged in as apport.academy@gmail.com. Great. So we have a Git repository and we are linked with our Heroku account. The next step is to prepare our code to be deployed on Heroku. Right now we have some code, but we need to tell Heroku what kind of code it actually is. We need to create a file that's called system properties. Let me just double check. System, I can't tell you. Let's try it again. System.properties. Let's add it to Git. And we need to add information that we are running Java runtime version 1.8. That's it. Then we need to create another file that's called proc file or proc file, which is a process file. And it tells Heroku that we want to run our application as a web server, and we want to run our application by running Java with jar AppPort Academy, or use the name of the jar as you chose it. The name is specified in our shadow jar. So if you want to rename it, just change this name. Awesome. So now we have source code. We have Heroku prepared to accept our code, and we tell Heroku how to run our code. Finally, we need to set up Heroku to actually build our project. We are building project, or oh no, I forgot this. We need to link Heroku Git Remote as AppPort Academy. We need to add Git Remote to Heroku. You can find this here. So let's do that. Now we see that Git Remote is set to Git Heroku.com. Now we can add all our files. Git add star, and its status now says that all these files are going to be included in our push to the server. Procs file, build Gradle, Gradle properties, tool. What's important for us is that our code is there, and system properties and procs file is included. So now we can, let's just add the git ignore, and let's commit this. And let's commit it with a message first deployment. Awesome. Now we have a commit. Now we need to push it to Heroku. Before we do that, we need to tell Heroku to actually use our shadow jar to build the project. To do that, we set a Heroku variable Gradle underscore task to shadow jar. This will tell Heroku to use shadow jar task to build the project. Awesome. And once it is done, we can say git push Heroku master. This pushes our commit, our change on the internet. It will take some time. You can see that there was some compression, and remotely the Gradle started. It downloaded the Gradle in a version we specified, and it's executing Gradle W shadow jar, exactly as we wrote it before. So this will take about 30 seconds. It seems to be long, 30 seconds. Okay, it's happening. This is the warning message. You can ignore for now. You see that build was successful in 43 seconds. It sees that we want to start web, and now it's launching it. It released the new version, and it tells us that our application was deployed. Let's give it a few more seconds to finish the deployment before we try it out. Verifying deploy, done, and we see that deployment was successful. Now we can take this URL and change our host to the value we got provided. So we are calling the internet apport-academy.herokuapp.com/hello world. And voila, we got 200 OK in 60 milliseconds, 600 milliseconds, and the response, hello world. Great, our application is now on the internet. I will give you again a few more minutes, so please let me know if you have any questions or if you need any help, anything to be repeated. And if you are ready, just use the green button. You can even call it from the browser. Hello world. I see 2 yeses, so let's wait for one more. With this, we are basically done with our deployment. We can call all our endpoints, including the ones for creating expenses. So let's try it out. And we got expense with these values created with ID 36. Let's create a few more. And let's retrieve those expenses. They're there. We got 3 yeses, so let's continue with our optional task, which is the database. As I said, Heroku offers us 10,000 rows for free, which is more than enough for our pet projects or generally small projects. Create Heroku PostgreSQL or PostgreSQL. This will create a database for you. The database is going to be empty as it wants you, and it will have random name. You don't have to worry about it. So the next step is to configure our code to config. And here we got the information about all our configuration variables. We see that our previously set variable Gradle task is set to shadow jar, awesome. And we see that we have database URL, which uses Heroku connect string. We need to change it a bit or parse it. The rule of thumb is that you should not use or you should not show this URL on the internet, for example, as I do. But I will delete this database, so I'm not worried about it right now. And now we can connect to the database and actually do something. First, we need to install our dependencies, some libraries that will help us to communicate with the database. So let's add these 4 lines into our build Gradle dependencies over here. This adds Expose library and its core, data access objects, and Java database connector. This will help us to actually communicate with the data, to use functions to communicate with the database. And finally, we use PostgreSQL driver, which actually connects to the database. Let's refresh our build. And now we finally get to write some code. So what we can do now, or what we need to do, is to create the database connection. That's not that difficult. We just need to modify or to add few lines of code into our project. So let's use database dot connect. First, we are going to use this fourth method. First is the URL. The address for our database is in our database string after the @ sign till the end of the string. This tells us where the database lives. It lives on some server in AWS, and this is the name of the database. Now we need to tell our connector which driver to use. So let's specify driver, and we are going to use regular PostgreSQL driver. So sorry, I put the comma here. PostgreSQL.driver. Now, and finally, we need user and a password to connect to the database. So let's use user. User is located here without the. And finally, password, which is again string, and password is this long string, again without. There we go. Now once we run this code, our application is going to be connected to the database. But we did not set up database in any way yet. Regularly, you would do this once per application or per service, and definitely outside of your API server. But for now, let's just create maybe temporary endpoint, and let's call it post/setupdb. And in here, we'll create, or we will do one transaction. Transaction is a set of database commands that need to be executed as in a single database change from before to after. If we have 5 statements in our transaction, all 5 statements need to be successfully executed in order to have those statements to take effect. If any of these fails, the change is rolled back and nothing actually happens. Let's import it. And here we are going to create our tables. Our table needs to be defined somewhere. For that, let's create our another file. Let's call it database kt. Let's edit, and let's create an object in our database, which is going to be object expenses, and this object is going to be a table that uses integer as an ID, 1, 2, 3, 4, 5, and it has these columns. Which columns or which fields our expenses have? Amount, currency, vendor, and ID, which is automatic. So we need to add these 3 fields, these 3 columns. Let's use value amount, and this column is going to be float with a name of amount. Another column is going to be currency. This is going to be a car type called currency with a length of 3, because our currencies are, for example, USD or EUR for euro. And finally, we need to add a column for vendor. Vendor is going to be varchar because it can be a string of any length. Let's see, vendor, and let's say maximum length is going to be 50. This creates our table, or this is the definition of our table. To have it created, let's use sysutils, right? Oh no, schema utils, sorry. Schema utils dot create, and what we want to create, table expenses. Is it right? Oh, no, it's not. Awesome. To see what's actually happening on the background, we can add logger, which is going to be our standard SQL logger. Now we can restart the server and try it out locally. So let me start the server. That's surprisingly slow for some reason. Okay, and something went wrong. What happened? It looks like my internet connection is down. Can you hear me?
Yes, I can hear you.
Okay. Now it's green. Okay, so let me try again. Oh yeah, I forgot something here. This is just the address of the server, but we need to use Java database connector for PostgreSQL and / our server. So let's try again. Awesome. Now we started our server and we are connected to the database. We can go to this endpoint and have it create our database. So let's do post on it. And set up EB found. We miss the response. Call dot respond. Let's say created. Yes, just a detail. But what's important for us is that in our log we see that this query was executed on our database. It says create table if it doesn't exist with fields ID, which is a primary key which is automatically incremented. It has amount, currency, vendor, and specified as we requested. So float, character, and varchar. Cool. Our database is now created, so we can actually store something in it. As you probably remember, last time we used files to store the data, to store our expenses in. So we can now replace all this with our storage to database. So let's just delete this. And simply start a transaction here that says on our table expenses, we want to do in insert. Now we can say that we are inserting some amount, and we are inserting value that we have stored in expense dot amount. The same can be repeated for currency, with the difference that our currency is enum, so we need to access the name value. And finally, our vendor, which needs to be set as this is. Now, you probably remember that we can rename this if parameter, so just to remind you, and because I like it more, let's say db expense, and replace it like this. But it's just a detail. What is more important for us is that we want to return the ID of resource we created to the user. That's actually quite simple, because inserts allows us to access the ID it actually created. We can type get, and on table expenses, we want ID. Now this ID is a specific object, so to access the value of it, we just need to add dot value. Now we can store it into some variable. So let's just say that we have variable expense ID, which is going to be of type int, and the initial value is going to be null. And here we can say expense ID is this value. Finally, we can use this expense ID in our response to provide it to the user, to our client. Let's restart the server. And let's try posting. Remember that we have this only running locally, so we need to use local address. So let's post to expenses and see what happens. We have an expense created, 201, with ID 1. If we create another, it should be ID 2, and it is. So now we are storing our expenses to database. But we can't deploy this yet, because our post/expenses uses database, but all our endpoints, other endpoints, are not. So if we do get/expenses, we are still reading the expenses.txt file. So keep that in mind, that this change needs to be done at once to avoid any unpredictable behavior. And let's implement get/expenses. Also, you can notice the queries that are being executed. It's simple insert into our table these values. So to implement get, again we need to remove all this because we don't need it. What we need instead is to read our expenses from the database and parse it somehow so that user eventually sees JSON out of it. So first, let's create start expenses variable, which is going to be empty array list of our expense. This is not the DB object, but this is our object. And now let's fill it. First, we need to fill it with something. So first, let's obtain the data in our transaction. Again, our transaction is going to be on table expenses. And this time, we don't want to do insert, but we want to do select all. This selects everything from the database. We want to iterate over this and create our actual expense objects out of it. So let's iterate For each, again, let's use start expense, for example, and we want to add it to our stored expenses. Stored expenses, add. But we can add only expense here, not the database object that we received. So we want to create an expense object out of this stored expense. This won't work because our expense, which is in expense KT, does not have required constructor. So let's simply implement it. We know how to do this because we've learned it like 3 to 4 lessons back. We need to implement constructor that's going to take the result row. So let's call it stored expense, which is of type result row. And this constructor is going to call the primary constructor, and it will just simply fill it with the values we obtained from the database. So we can say the ID is stored expense in a column expenses, which is the table ID, which is the column. Now we are accessing the ID, and because it's incrementing and special object, you want to access value. This way we access the ID. The second field we need is amount. It's in expenses amount column, and that's it. It's float, so we don't need to do anything with it. The third is currency, but our currency is enum, so we need to parse it to this value. It's currency dot value of, and it's going to be the value we received from the database, expenses dot currency. And finally, we need vendor, which I bet you already know how to access. So start expense, expenses dot vendor. Now we have a constructor for expense object out of result row, out of the row that we received from our database. We go to application, this should be fixed. It is. Now we can simply restart the server and see if we can access our data. Awesome. Our server started, and let me call locally /expenses and get method on them. And we see that we received list of expenses 1, 2, 3, 4, 5, and the latest one we created is 5. So we received all the expenses we needed. So awesome, we have it implemented. All we need to do is to push it, or actually we should implement other endpoints as well, but I would like to leave this for you as a homework if you're interested, not that anyone will check it. So just to finish our lesson, let's create another commit. Let's add everything. So we are changing application KT, expense KT, and we are adding another file, database KT, and we are modifying build Gradle. Let's commit this, commit -m, let's say first database usage, and git push Heroku master. It will take again some time, something around 30, 40, 45 seconds. Let's wait for it. Now it's building our archive. Just for you to know what this does, this uses Git, our program. It pushes code on the server to our remote that we added as Heroku, and master is the name of the branch. It's the main branch of our code. So now our build succeeded in 30 seconds, and now it's being launched. It seems it was deployed. All right. Let's wait for verification. And done. Now you can change this again back to our internet address. And if we make this request, we should get the same response. The file should not be read at all. The file that we used before. And voila, we see that it actually works. So our next steps would be to implement update, read, and delete of a single expense. For that, you have methods select, update, delete where on expenses object as we used here. As we use here, select all. So for example, to select just one, we will use transaction expenses dot select, and that's it. Just some final notes. As you saw, I hard-coded my database connection values here. In reality, you should never do this. You should never hard-code any credentials to your code. But for this case, I'm comfortable with doing it. And that's it. If you have any questions, just ask. If not, thank you for your attention and see you next week.
Thank you.
You're very welcome.
Thank you very much. Bye.